from Testhouse, and they're from UK. We would be starting this session in a minute now, and you have a question and answer panel in case if you have issues with the voice or if you have issues with the slides not visible, anything, you can just ping in question and answer panel. I would be answering. Now, in case if you have any technical question related to webinar, just post it into Q&A. Adrian would answer at the end of the session. So, Adrian, over to you.
Thank you, Shakila. I'm Adrian Hammond. I work for Testhouse based in London in the UK, and we're going to talk about load testing with Visual Studio today. Testhouse has offices with headquarters in London and a major office in India and a number of offices elsewhere in the world. We can offer consultancy in testing and help you with training with testing or actually performing testing. We've got a number of companies, customers around the world. Here's just a few of them. At the moment, we have a number of projects involving for the financial industry and the retail industry. But the main part of today's talk is about load testing, and these are the main topics I want to cover during today's talk. So what is load testing? It's a big topic. It's one that needs planning. We need to identify what is our goal in doing our load testing, what is the purpose of this testing, and plan how we're going to do it. We then need to actually do the testing. We need to arrange time on the system so that the testing can proceed without interference of other jobs, probably without the testing being influenced by other people using the system at the same time. So we might need to run the test out of normal working hours, just so that we can run the test on a machine that we have also ourselves, so we get a valid test result. And finally, we need to report on what we've done. We need to analyze the test results and find out the details of what actually happened. So with our load tests, what we're trying to do is run multiple users using a website at the same time. We're trying to see how the website behaves with large numbers of users simultaneously operating on the site. So we can't have many people all at the keyboards, so we use virtual users, and the Visual Studio system manages that and provides a way of creating all these virtual users. So we're testing what happens over a period of time with these tests, and typically the tests use web performance tests, which is another part of Visual Studio. We can put in unit tests and also Code's UI tests into the mix, but that has other issues. Code's UI in particular requires a whole computer to itself because it takes over the screen and the keyboard and the mouse of the computer. So we can only have one user per physical or per virtual computer. So we need to start considering test rigs, how many computers we have within our test environment. If we're doing web performance tests, we can simulate a large number of users on one computer. Numbers of up to about 250 virtual users are thought suitable for use on one computer. If you need to simulate more than 250 users, it's worth considering having more computers in your test rig system. Again, it depends on the complexity of the test and the time the test takes and the number of users to what we do. But be aware, this sort of testing imposes a high load, or can impose a high load on the system you're using. So be careful that you're not unintentionally doing a denial of service attack, and what appears to be a denial of service attack on the sites you're testing. And in particular, if your web test visits other websites, if it pulls pages off of other websites I'm thinking about the advertising websites and the click counting websites and just support websites with bits of JavaScript or CSS that people commonly use. If you're load testing, be careful that you're not putting so much load on those websites that they think that you are attacking them. So Visual Studio supports these four main sorts of load testing, and load test can use the three types: performance for web, for unit test, and coded UI. And you need Visual Studio Ultimate to do load testing. So when we're creating a load test, we can start by using the load test wizard, which asks a series of questions and populates the basic load test. When we have a load test created, we can enhance it, change it by using the load test editor. Any of the settings on the load test can be altered. The results of our load test are stored into an SQL database. SQL Express is fine, but remember that has a fixed maximum size for the database. So if you're going to do a big test, or you want to store results of many tests, then you probably need to go to another paid-for SQL version. Whilst the test is running, you get a view of what's happening in the test, and it's a partial set of results which are built up slowly, and it doesn't show the full details whilst the test is running. When the test completes, you can then use the full powers of the load test analyzer to see what's happened in your test. To create a load test repository, you can go through here, this stuff. There is a standard script available within the, basically the link at the bottom of the screen, which will create a load test repository in SQL for you if you need one. Once you've created it, it's there, you can run multiple load tests against that same SQL database. So, I'm going to show you a demo of creating a load test. We normally put these into a project which has web performance tests as well. In this particular case, I have a web test project which has two web result tests, and I created that using a normal file, new project name and use, going through creating the web performance test. And then I clicked OK. Here I'm going to cancel this screen because I already have my load test, so web performance test created. So if I right click on there and add something new, I can add a load test off of that or off of the new item menu. I'm going to do a simple route there, which brings up this wizard, and the wizard will go through this set of settings for me. I think it's useful to have a short think time between test iterations. I ran a test recently where the website was reporting an error on the very first HTTP request that was sent, and so it was very quickly returning a bad response. The load test was sending off a request again, and the network was flooded with these request and error messages, and the whole system was running very badly. Scenarios are useful. For example, when we have a website where we have a number of customers visiting the website, and we want to have a load pattern they impose, and separately we have the people using the website, so the managers of it, doing a second scenario for them. The load test pattern, we can have a constant number of users, or a step load where we start with that many users, and every that many seconds we increase the user count up until we get a maximum value. There's a third case, which is not available on this screen, that's goal-based, and I'll show you that later when we're doing editing of the thing. And so the step load is commonly used to see how the system performs with a low number of users and then increasing the number of users slowly over time. When we've got our tests set, we can have a number of patterns for how the test should be modelled. The top item there says we want to try and run the tests in a fixed proportion so that at the end of the testing, the number of occurrences of each test fits some particular pattern. The other option there, the last option, effectively says we want to run test 1, then test 2, then test 3 in order for each virtual user. Having set the mix, we can then add our tests. We click the Add button and then just add the individual tests into the test mix. So you see there. And now we can adjust the proportions of the two tests just by dragging the sliders to and fro. If we've got a number of tests, it makes sure that the total adds up to 100 and it won't let us adjust the proportions so that they're not 100%. And we can just reset it all to equal quantities by pressing the Distribute button. We can specify a number of different network types in our load test and just add new types, and then we can choose between all these different variations of the load test. We can add multiple ones in there to give different performances, and basically this affects the speed at which things happen. Now, to use anything other than LAN, you need add-on software which I don't have on this computer, so we'll remove that. Again, we can simulate different browsers sending messages to our website. All is now normal browser types. And again, we can adjust the proportions. And you see now trying to drag these things around, but because it's above 100, it won't let me increase any proportions until I move one of them down to a lower value. And again, I can redistribute the proportions to make them as equal as possible. I can add other computers into the mix so that I can get performance data out of other computers. For example, I can get IIS and SQL data out of some computers. I might get SharePoint data out of another computer. So I just enter in that box at the top either the computer name or its IP address and add it to the mix and then select which counters I want. Anything that can be viewed with Performance Monitor can be selected here. There's a standard set which is provided at this stage. Later on in the screens, when you edit the data, you can add non-standard performance counters. You can even create your own performance counters using the normal mechanisms for doing that and add those into the mix. The time the test takes, we can either specify a duration for the test, or we can say how many iterations shall be run and then the test completes. For this demo, I'm just going to set 1 minute because it's a simple test. Sampling rate, this is how often data is recorded and written to the database. 5 seconds is good for small duration tests. If your test goes above 2 to 3 hours, then probably go to 15 seconds. If your test goes over perhaps a day, then you might want to drop this down to 30 seconds or 1 minute. Because the amount of data that is collected is large, and it will fill the database or create a very big database which can take a long time to process in subsequent stages. You can add a description for the test which will be held in the database so you can see what the purpose of that test is. When the list is complete, it gives this layout for the load test. Now, I like to ping open the properties window just because there's a lot of aspects of the test that are modified via properties. So we can change the scenario name, we can add new scenarios here. We can adjust the text mix by clicking on these ellipses. Here, for example, things like much the same panels we had before in a wizard. At this point, we can access the third set pattern, a goal-based pattern. The goal-based pattern adjusts the user count as specified in this set of values, so that the performance monitor counter shown there is kept between these values. Now we can adjust all these different things. So we could at this point specify perhaps an SQL database computer and say that transactions per second shall be maintained between some numbers. Or we could look at a web server computer and request that the network traffic was maintained between certain values. And the load test will try and find the number of users that the system will support to keep the counter within those values. But for this test, I want a step-based count, so I'm going to set the initial user count to 10, and the maximum users to 60, and then every 20 seconds, every 15 seconds, I'm going to increase the user count by 20. The step ramp time is useful. When it's 0, it says have all the users in one hit, or with a step ramp time there, it says add them slower. So the duration of the step is still 15 seconds. 2 of those seconds are used to increase the number of users slowly. Now in the run settings, I can access the duration of the test, how long it takes. I can have a warm-up period, which allows the system to get started properly before timings and counters are particularly recorded. For this test, a short cooldown duration is useful, and that says that any tests that are running at the 1 minute time are given a period of 30 seconds to continue running, rather than just chopping them off, stopping them very quickly. Now at this point we can also adjust the computers that are providing performance counters. I happen to know that Testhouse doesn't do anything useful. I added it just to show how we could add them, and indeed trying to get the counters out of this computer will generate problems. So we can remove it there. Because at this screen we can add other computers in if we have them in the mix. And that's basically how we create a load test. So again, let's think about the sorts of testing we can do. What sort of load test we want. Do we want to just check out the system basically works and performs okay for a small number of users, a smoke test? Excuse me, sorry about that. Do we want to actually stress the system? We want to run it under high load for a long period of time to make sure it all behaves, to look for memory leaks in our system, or consuming some other resource which is not properly returned. After all, our website may have to run all day, every day for a long period of time, serving real customers. Do we want to check the performance of the test of the website under different loads? Or do we want to see how many things it will support and therefore what capacities we want to support? So we need to, again, as part of our planning of testing, we need to decide what sort of load tests we are going to be doing, and we set the tests we're using accordingly, and we set the user load accordingly. So one purpose of creating the load test is to get a baseline so that we can measure how the system works on one configuration and then change the configuration of the system, perhaps add another computer into the mix, as in load sharing, or changing some other properties of the system, and then see how the system works with that change of load. So we need to be very careful in setting what the actual load pattern is. We need to make sure that system is being tested is only running the test suite and that no other significant activities are happening on the system at that time. And we need to know which parameters we vary between the two runs or between multiple runs so that we've got a good set of data for making sensible comparisons. Another possibility is benchmarking the system against, known standards. So you can report the performance of your system compared to someone else's, or get these standards endorsed by some other organization. So how do we run those tests? Well, I have another video here. So continuing the previous example, we can either right-click on here to run those tests, or we can use the icon there, and so those tests start with a series of graphs showing the progress of things, and underneath those details of the counters. Towards the top left-hand corner, we get a status, or full status of the test. Towards the top right-hand corner, we get durations of the test, how much time is remaining. The temperatures window doesn't actually help on this, so we'll dismiss that. So as the test runs, you can now see the graphs being built up. The red line here shows the user load. It started at 10 users, then the 2-second period increased by 20 users to 30, and another increase there. The test runs. And so there we get memory, the green and red line is memory and CPU usage of the systems running the test. We can change the graphs on these things by using the little down ticks there. I quite like to swap between 1 panel and 4 panels on that thing, so I can get a bigger view of the graph of how the test is running. And now in the top right-hand corner you can see the test is almost finished. It's now in the cool-down period with just a few seconds left to go. On the bottom left you can see it's done about 100 tests and about half of them failed. Now I expected a lot of failures because that's the nature of this particular test. So when the test finishes, in the top left corner, you see it telling you how the finishing is completing. On this summary screen, we can see the number of tests executed, the failures, and the average test time. The section below shows the pages that have been visited, and in particular it shows the slowest few of them. On the detail panel, each of the horizontal lines on this panel shows the activities of one virtual user, and the graph of the person is a copy of the selected graph on that page, so we can match the virtual users against what was happening on some particular set of counters. We can drag out this window here to show the whole area. You see on the right-hand side now the cool-down period and what happens there. The short gap, sorry, there's a loud vehicle going past, I hope that didn't disturb you. The short gaps there are the ones that you can notice between the things. We can look at the individual test results as we move the mouse around. The different coloured lines are set according to this panel in the top left-hand corner. On this particular test, all of the fabricant tests fail, so all the blue lines turn to red. So that wasn't particularly useful on this test, on this example. Also here, we can see the status of any particular test, and for some of them we'll get a test log. You could click there to bring up the log of that test. We can also visit this errors account, where you then get a series of tables with clickable counts of errors from the different tests or the different sorts of error. Clicking them brings up a panel, for example this one. If we stretch it out a little bit more, again we can see the test logs of the various tests that are running. Now by default the system will record up to 200 test logs for 200 failures, And here we see what's happened on this particular test, so further error in the application. Details of this error are not important to this presentation, just the fact that you see errors. Now you'll note that to the left of the cursor there's no little triangles against each of the request lines. This log is not as comprehensive as the log you get when you run the web performance test on its own. When you run it as a part of a load test, you get less detail there. But you do get the request and the response from the system. You do still get the context variables used in the request, and you do get the details tab. So there's a lot of information here to help you understand what is happening with your load test. Back on the load test summary itself, we have a number of different options. You'll see the sliders are the right of the graph and the left and the bottom of the graph, so you can adjust to different parts of it. We can add new graphs for showing other values. So, for example, we've got an SQL graph, or in this case, a graph showing disk activity. We can add the disk activity of various computers onto the system. So we can make our own graphs of any data that's available from the recorded performance counters. It's quite useful to add the user load from there onto the graph, so we get that. And if you want the graph to be a different colour, you've got plot options gives you that capability. So if you always want the user load to be red, which has some consistency, you can specify like that. You can also other things, for example, the scale on the graph. You have the automatic setting there. If you untick that, it opens this option here, so you can adjust the scale. Now in this case, just a small part of the graph is shown, and then the rest of it is shown as exceeding the maximum available on the graph at this scale. So we can adjust all our graphs by this kind of method, or we can go back to the automatic range adjustment as so. So any of the performance counters we have on our system can be adjusted by this, and after the test is completed, we can see what's happening by exploring different graphs and tables of our test. We have a number of tables available, so we can visit various things. There's no SQL monitors on this particular test. Here we can see the different pages that were visited in our load test, including the times for the 90th, 95th, and 99th percentile of visits to the pages, in addition to the maximum average and similar values. And also we see which network type was visited for that page and the total number of visits for that network. So there's a lot of data that's available here. We can copy all this data and paste it into a report or into a Word document, for example. The summary we can copy, we can do a select all and then copy that, paste this page into a Word document for other reports. We can copy these graphs and the tables beneath them as well to add those into our reports. And we also have the ability to export more or less any of the data into Excel for doing other forms of reporting or using the power of Excel to compare different things. We have another thing, off of this button here, we can manage results from different test runs, and there's an export facility, so we can export the data from our database to preserve it outside of the database, or for transferring it from perhaps the machine where we did our testing onto another machine where we're going to do our reporting. I've done a few tests where we've run the test from a virtual machine within the test environment, and then I've exported the results from the test environment to my local desktop where I do the reporting and finish the analysis of the testing. So, when we're analysing the test, we can monitor part of it whilst the test is running, and we can analyse more in more detail when the test has completed. We can use the Manage Test Results window, and by the way, that window is only available from a load test. It's not available off the normal menu. So we can monitor a test while it's running and get some data out, and more data when we get the results after the test has completed. The amount of data is obviously related to the length of the testing, the sampling interval. So a long-running test and a short sampling interval will generate a massive amount of data, so be cautious on that. Also, the number of computers that we are monitoring and the number of counters that we're collecting from those computers affects the quantity of data that will be collected. But we can use the data that we have gathered so that we can identify the particular problems in our computer system. Are there bottlenecks? Are particular things causing errors? And get an idea of where we might improve the system. Sorry, that slide shouldn't have been there. We should have a demo on But when the analysis is completed, we have the details view off of the web results. We can zoom, we can drag these sliders to and fro to zoom this window to different parts of our test. On the graph view, we can select a particular graph which will then be displayed down here, so we can correlate particular graph aspects against what the users are doing at that time. So we can see particular patterns of usage. I had a test where the total number of errors was huge, but when we started looking at this graph, we saw one long red line, and a second long red line, and a third long red line amongst a whole lot of tests that had passed successfully. And that was tracked down to a sticky session problem within the application. Something had gone wrong, and all subsequent tests for that virtual user failed. Some sticky event within the application. So looking at this virtual user chart can be very helpful in understanding what the system is doing. So when we get more load on our computers, we need to start creating bigger systems. The test I just demonstrated, everything was running on the one computer, including the application I was testing. And that's perhaps not a usual scenario. The more common one is we run Visual Studio on one computer, and it runs the whole test and visits a website on a different environment. As we add more users into the virtual user mix, we start needing to create test agents and test controllers. The test agents actually run the tests. The test controller tells the agents what to do, and Visual Studio tells the controllers what tests are required. Again, as the quantity of testing and test data goes bigger, you might like to move the SQL database onto its own computer so that the amount of data that's recorded is not causing performance problems on the computers that are running the tests. So our test simulation consists of this mix of computers, the client computers where we just develop the tests and generally view the results, the controllers that administer the testing and gather data from the agents that actually run the tests. But this provides the ability to make our tests bigger, to simulate much bigger loads. Again, the numbers up to about 250 virtual users, you can do it all on one computer for the testing. Broadly speaking, different loads might require more computers. But we have a lot of flexibility for running large tests. Now, earlier versions of Visual Studio limited the number of users you could have, but with Visual Studio 2012, you can have effectively an unlimited number of users by using agents and controllers. So here's some more words about what the controllers and the agents do. I'll just let you read those words. So we can select particular properties on different agents. So that different sorts of tests are only run on some agents. It might be that particular hardware or particular software facilities are required and they're only available on certain agents. Again, if we're using coded UI tests within our test mix, we have to arrange that only one test is run on an agent at a time. So we can have a large quantity of virtual computers and run a number of coded UI tests, one on each virtual computer, but coded UI requires a whole computer for itself. To manage the controls and agents, we have additional panels within Visual Studio where we set up the properties of the controllers and the agents. So these panels basically show how we control the agents and the controllers. I don't want to describe these in detail, I just want to make you aware that they exist. We can gather performance data from multiple computers. A system I tested recently had a mix of SQL computers, of application server computers, of web serving computers. Most of these were 2 of each, so they've got fallback facilities. So we were monitoring 12 different computers in this mix, monitoring different performance counters from the various different computers. So we can add multiple computers into our system and then collect performance data of different categories from different computers, depending on what their job is within the system. Again, the more computers you add into the mix and the more performance counters you collect from them, the quicker or the larger the amount of data that's recorded in the database. So, to recap on the sorts of activities of performance testing, we've got to identify what the environment is, what the computers we want to monitor are, what the goals of our testing are. There's a number of planning things that need to be done to set up the test so that we are actually performing a useful test. It's so easy just to dive in and create a web test, a load test, and then wonder afterwards, what have we learned from that? So planning is important to understand that we're doing the right things, we're recording the right data. And then we have to configure the test environment, set up the controls and agents if required. We have to arrange that we have use of the computer system in a way that our tests will not be adversely affected by others using the same system. Again, that might require out of normal hours working. Making the test is relatively straightforward, as seen in the demo I did earlier. Executing the test, it's worth monitoring the test whilst this is happening, particularly for a long-running test. It's quite easy to have a slight misconfiguration of your system so that without expecting to, you stop other work happening on your system, effectively doing a denial of service attack on the system. So when you're running performance tests, have people monitoring the various systems in your entire network to make sure that the test is only visiting the parts that it should be visiting and that other parts aren't badly affected. It's quite common to have production environments and test environments which are actually linked in some sense on the network, and just a slight misconfiguration of that network can mean that bits of the production system are being used by the test. So monitoring the test is important. And when the test is completed, we've got to analyze the test to extract useful data from it to see what happened and present that data to our customers. So that's the presentation. A little bit about Testhouse again. We've got a number of sources of information where you might like to learn more about Testhouse and what we've done. We've done a number of presentations previously, and they're available generally on YouTube. Our Twitter account has a number of things about what we're doing, and so you might like to monitor that. So the final slide here, some contact details for us at Testhouse. I know a number of people watching this presentation are based in India, so if they'd like to contact Shalu, that would be that. Anyone else can contact myself or Melanie here in London. I'm perhaps better for the technical aspects, and Melanie if you'd like to know about Testhouse as a company. So that's my presentation. If there's any questions, I'd be happy to take them. Let me have a pause. So the first question is, what's the difference between step duration and step ramp time? When doing a step load pattern, generally we're saying every so many seconds increase the number of users in our test by a particular number. If our step ramp time is 0, then the number of users that increase will be added all in one go. So if we're adding 20 users each every minute, then the number of users will go from 20 to 40 in a very short period of time, as quickly as the computer can achieve it, and then in a minute's time after that, it will go from 40 to 60 as quickly as the computer can achieve it. Hitting the system with that many users all in one go might not be desirable. It's nice to have a slightly cleaner, a slightly slower change in the number of users. So the step ramp time says add those users over a period of time. So if we have a step duration of 1 minute and a step ramp time of 10 seconds, then what we'll get is 50 seconds of the number of users being constant, and then over a 10-second period, the number of users will increase by the step increment, and then another 50 seconds of constant users, and then another 10 seconds where the number of users increases slowly. Someone asked, can we increase the load while the test is running? There are no particular buttons or things you can click while the test is running to adjust the way it is running. There's no built-in facilities for that. So you have to set the pattern before the test starts and then use that pattern as the test proceeds. It is possible to write things known as load test plugins, and they can adjust the counters whilst the test is running. And in fact, plugins can be written to adjust almost any parameter of the test dynamically whilst the test is running. So I suppose you could write a special plugin which interacts with the user to take numbers which the user types in, but it's not a built-in facility of the system. We're just looking through the question here. Some of the questions are complicated, and I will can reply to them after the event. If you've got any particular questions, then please feel free to email me or Charlotte or Melanie on the addresses given on the slide. A question about choosing agents to execute particular scripts. That facility is available. You can specify the properties of an agent, and you can specify the properties of a test, and then the system will match up the agent, will match up the properties so that only particular agents run particular sorts of tests. Okay, a question about what versions of Visual Studio run load tests and so on. Load testing is available in Visual Studio Ultimate Edition. From a testing point of view, the main difference between the Ultimate and Premium editions of Visual Studio is the ability to do web and load testing. The Premium edition of Visual Studio adds coded UI testing above the Professional edition. So the Professional edition is, generally speaking, the cheaper of the three. That doesn't do coded UI. The Premium edition is the middle price version. It does coded UI testing, and Ultimate is the most expensive, and it supports coded UI testing and also web performance testing and also load testing. A question about whilst doing load testing, wanting to know how the web server is behaving. And will load testing allow us to do that? Yes, provided the aspects of the web server you want to monitor are available via performance monitor counters. Any performance counter that your web server provides can be monitored via the load testing system, and whilst the load test is running, you can add a graph to the display and add the particular performance counters that you're interested onto the graph that's being displayed. The graph that is displayed whilst the test is running are, I believe it's 100 samples are taken, and so it gives not the full fine details of that graph, but it gives a kind of summary graph to show how the test is running, and as the time extends, so that the graph will turn into the early stages into a less and less detailed summary of what happened. which you can monitor what your web server is doing via performance monitors. A question here about, can we see the response time of requests in the report? Yes, the output from the web test, sorry, the output from the load test on the tables view, you can see the page times for each page that was there in the test, and with that you can also see the number of times that page was visited, the maximum, minimum and average times it took to load that page, and also the percentiles at 90, 95 and 99%. So that will show you that 99% of visits to that page occurred within a particular time. So you can see the top end of how pages are being rendered, no, not rendered, being delivered by the system under test. Note that web testing and load testing don't use browsers, so the times that are measured are the time it takes for the body of the page to be delivered from the website to your web server, to the system doing the test. It does not measure how long it takes a browser to draw the picture on your screen. Some web pages are very complicated and can take a long time to actually draw on the screen. So that time is not available from web testing or load testing. What is the main advantage of load testing apart from other testing solutions? There are many sorts of testing for getting to different aspects of how your system is running. We can do functional testing to see, does, in general sense, the system work? Is the correct information displayed? Are the correct results returned? Load testing is about seeing whether our system can support multiple users and lots of users at the same time. If we look at a commerce website or a banking website, we have a system where potentially a large number of customers of that organisation want to visit the website at the same time. They want to view their own personal data and transactions in that website, or maybe they want to do shopping on the website. And so we need to know that the web server can support multiple customers at the same time. When we look at companies like Amazon or some of the airline companies, they can expect to have thousands of customers visiting their website at the same time, trying to purchase goods from them. And if their websites do not support thousands of users at the same time, they are going to lose customers. And that they don't want. So they are going to put a lot of effort into making sure that their website properly supports a large number of users doing various shopping related activities and are viewing their accounts. So they, I'm sure, put a lot of effort into doing load testing to make sure their system supports the correct number of users. I'm sure we've all heard on the news where our government has produced a new website showing some interesting aspects of our community, some historical data perhaps. It's reported on the television news, and almost immediately a large number of people visit that website, and then the news the next day said, this new website, it broke immediately because so many people tried to use it. So we need to do load testing to try and avoid that sort of circumstance. Question on the maximum number of users we can put in a load test. Essentially, it's unlimited with Visual Studio 2012. The limits are based on the amount of computer resources that you can apply to the problem. So if you have sufficient computers, you can put any load that you require. There's a rule of thumb that perhaps one computer can support 250 virtual users, but that's based on just the performance of that computer and the amount of memory and the amount of processor power it takes to support each virtual user. Statement that the response time is not in web performance is there in load test. My recollection is that the web performance test gives you the times for each individual page, but it's showing you the time for each transaction. It's not collating multiple visits to the website and giving you summary values. So I believe that the individual times are available from a web test, and in the load test, the data is gathered together and summarized to give you averages and maximum and minimum of various times. In terms of which databases you can use to store the results, I believe most versions of Microsoft SQL Server since about 2005 can be used to store the results database. The SQL Server Express can be used, certainly the last two versions of it, and there was a change within some of the last ones which doubled the size of database that could be stored. I think it was 4 gigabytes and it's now 8 gigabytes. But if you're not using the Express versions of SQL Server, then the database size is effectively unlimited, or it's limited by the size of the databases that those systems can support. So I think that's all of the current set of questions. So if any more questions we'll take offline. I can actually there is 1 or 2 more, but we're running out of time, so I apologise for cutting off early. If you've got any questions you'd particularly like answered, please email to us. And I'd like to say thank you very much for listening to our presentation. I hope you enjoyed it. I hope it's been useful to you. And please do visit the Testhouse website and let us know what you think about the presentation. Thank you, everyone.
Thank you so much, Adrian and Mel. Well, if you have any questions, you can send an email to the email ID that is provided on the screen, either to Adrian, Melanie, or Charlotte. And if you have any other questions regarding recording, please send it across to me. And we will be sending all the recordings by next week. Thank you so much. Thanks, Adrian, Mel.
Okay, thank you. Bye-bye.